Alibaba just released Qwen 1.5, which is a collection of 6 different models. They have different sizes, 0.5 billion, 1.8 billion, 4 billion, 7 billion, 14 billion, and 72 billion. They claim that they are behind GPT-4.5-Turbo, but that they are surpassing Claude-1.2, GPT-3.5 on various benchmarks. So Qwen 1.5 is a transformer decoder based architecture. It is based on transformers with Zwicklu activation, attention query key value bias, group query attention, mixture of a sliding window, and full attention. What is really interesting that every model comes with a context length of 32,000, which is pretty big. Let's try the biggest model. So let's try Qwen 1.5, 72 billion. I think this should be the best one for coding because it's the biggest model. I already tried to play around with really little models, but of course a 0.5 or 1.8 billion model is not really capable of coding. The 4 billion model is already capable, and then with the 7 billion model you can have really a lot of fun. And the 72 billion model is perfect for more complex tasks. So let's try it. And we want to calculate P with Monte Carlo integration. And we want that it's using type hints and Google style documentation. So the idea is that we have some square, and in the square is a circle. We are sampling random points inside, and then we are looking how many points are in this total area and how many points in the circle. And if we subtract these areas from each other, we can guess what's P. And at first, let's check. Yeah, it uses Google style documentation. It's using type hints. That's looking good. What's going on here? Why is here P? I hope it's only to compare something. Circle area. Okay, it's for some debugging things. But seems like let's just copy paste this code and run it. I just will delete this part. Perfect, even a Wikipedia reference, that's great. That's good documentation. Like you could put this in any documentation system and you would have a beautiful documentation. I'm not happy with this one. I'm afraid this value will leak accidentally. So circle area. Okay, it's only used in the debugging. That's fine. Still will delete that and this, and we don't need some debug things. Okay, let's run the code. Ooh, looks good. Of course, this is not 100% accurate. With more points we are sampling, it will become more and more accurate. But because we cannot sample infinity points, and also there are some precision problems. Like always, it's just approximation. It's not the original P, of course. This is great code. Now let's ask Qwen if it can optimize this code. So we just copy paste this code, and we want that it's optimizing it and adding a benchmark. So please optimize is code for speed and add a benchmark. It's doing some benching. Let's run this. Okay, we need 7.7 seconds. Maybe it just increased the number of iterations so we can guess the time accurate. But I really want that it's making this code more fast. Okay, but this is fine. We have now time, 7.75 seconds. So I will just take it again, copy paste it, and ask it that it should optimize this code for speed. Please optimize this code for speed. There are like a million different ways to optimize this for speed. We could work with NumPy, or we could use some arrays. There are and do this in parallel and not in some for loop. Like, there are so many ways. I'm just curious what it will do. Okay, this is new output. It used NumPy. Great. Great. Okay, wonderful. So before it was 7.75 seconds. What is the number of iterations? This number. It's important that we choose now the same number of iterations. If not, we cannot compare the result. So I did this. Maybe the numbers are already the same. Yeah, it's already the same. Let's run this one. Great. Great. 10 times faster. Wonderful. Of course, if you are in some high performance computing thing or some stock trading thing, you need maybe more speed. But I think in 99% of every case, if you take some code, some standard Python code, and now you give it Qwen, you say, make it faster, and you're 10 times faster. And then you're happy, your company's happy, everyone is happy, this is great. Let's ask ChatGPT-4 to take this code before, optimize it for speed, and compare how many seconds it takes. Optimize this code for speed. Okay, it also want to use NumPy. It want to use NumPy for random number generation. But the great thing is with calculating pi, you already immediately see if your program is working right or not, because you know the value of pi. So this is great for benchmarking. I also can recommend, if you want to learn some CUDA, maybe implement this one in CUDA. This is great to learn it. Okay, 0.64. Now ChatGPT. Oh, 0.51. A little bit faster. Let's just run both again. Okay, 0.51. 0.5, that's in the margin of error. I would say it's similar. And where do we get our random numbers? np.random, but maybe here also. Yeah, also. Okay, it gives us basically the same solution. Maybe I should disable my ChatGPT photo subscription. This is great. Yeah, seems like this is a really great, useful model. We also could ask Google Bard now. I hope I don't embarrass Google now. Please optimize this code for speed. Also, it's using NumPy. It says numpy.sum is already calculated in a distance variable, which reduces computation. That's great. Okay. Okay, I'm excited. Also have to run it multiple times. Oh. Again. Okay. Okay. Yeah, seems like if we maybe run it the first time, then the library is more slow, and the second time, then it's fast. And it's similar. Okay, so we can... seems like Qwen, ChatGPT and Bard is using the same approach. And we will not get more. Okay, that's it. I hope you had fun. And if you like this kind of content, then please subscribe and like this video. Thank you for watching.